Revision in here, our cubic functions. It's a polynomial of degree 3, which means it's got an x cubed coefficient in it. Again, if a is greater than 0, it's a positive cubic. If a is less than 0, it's a negative cubic. There's my graph and my cubic. Looks a little bit like that. That's positive x cubed. Negative x cubed is opposite direction. And don't forget that that point in there, that's my point of inflection. Okay, so vertical translation plus k, horizontal translation, it's minus h inside. So that means the point of inflection is at h0, point of inflection is 0k. So it's shifted up here, shifted to the right there. All right, and there's the general form. So nothing really new in that. It is possible we'll get it in factored form. If we get it in factored form, it just means that these three terms are my intercepts, aren't they? Because that's the x value that makes the function equal to 0. All right. Now, so if we have three separate factors, it means I have three distinct intercepts. Yeah, that's them there. If I have a repeated factor like I have here, well, anything to the power of 2 is a turning point, isn't it? So that means that b is a linear factor, so it goes through. I'll probably make it a bit more accurate. Let's get rid of that. And say b is a linear factor. A is a repeated factor, so maybe this one goes like that. Obviously depending upon the size of A and B and things like that. Okay, so it's a repeated factor, so that's a turning point, that one there. Okay, so that's what that sort of says up here. A repeated factor in a cubic function indicates a turning point. It touches the x-axis and goes. All right, so if we do a quick graph sketch in these ones here. So let's just do an axis. So x-intercepts are at x equal to 0, x equal to -1, x equal to 4. The y-intercept, put x equal to 0. Sorry, the y-intercept, put x equal to 0. I get 0 times all of those, so it's just 0. So it's going through 0. It's going through -1, which I'll call out here, and up to +4. So let's be consistent, Anthony. Whoops. So call that -1, call that +4. Y-intercept was 0. So it's a positive cubic, so it's going to have to come down, get back through there, and go up through there. Now chances are it goes miles down, but that's okay. All we're doing is basic shape. We don't know turning points yet. Okay, so we don't know. Question B. Let's pop the graphs in. So what do we know here? I know that at x equal to 4 is an intercept, and at x equal to -6 is actually a turning point at the intercept because it's a repeated factor. Yeah, and then if I put the y-intercept, x equal to 0, I'm going to get y equals 4 minus 0 times 0 plus 6 squared, which is 4 times 36, which is 144. So up here somewhere. So what are our points? We have a turning point at -6, an intercept at +4, and it's a negative cubic because of the negative x there, so it's going to come down, touch, go through there somehow, who knows where it turns, and come back down through there. Okay, so something like that. This turning point here could be there. I just made it there probably to help it fit. All right. So let's think about our function notation. On the same graph, f of x minus 2. So the whole graph shifts down 2 units. So if that's 2 there, down 2 units there. So you could almost argue this could all, there's my new x-axis, which means that point there is here. That point there is there. That point there is there. Turning point just pops down a little bit from it. So we just, turning point there. So if we just get our graph in, there's my turning point up. And the whole thing is it's all 2 units below, isn't it? Everything's sort of 2 units below it. Let's go to f of x plus 2. So everything's 2 units to the left. So let's go, that's at the point 0, 2. So it's across here to 2 units across there. That intercept there is going to be 2 units across. Maybe there. This intercept 2 units across. So maybe there. About there. So everything's the same. Not too sure where the y-intercept is, but we're going to draw our graph, come up through here like this, and again this time we're 2 units to the left. Finally, 3 times f of x, well that's the same as dilation by a factor of 3 from the x-axis. So it's the point x3y, isn't it? So it's the y value gets multiplied. So the y value here is 0, the y value there is 0, the y value there is 0, so it's just 3 times 0. Y value here is 1, so it comes up to here to about 3. That turning point, 3 times bigger, so maybe about there. So just everything is sort of steeper. So we come up, down, and we just get everything up 3 times bigger. So something a bit like that. All right.